everyone. So in this section, so this is our section for Monday, August 30th. So this one we're going to be talking about interval notation. So this is section A9 in the book. Again, that's Appendix A. If you go to the e-text, you got to scroll all the way down and then go to A9 if you want to reference this in the book. So this is going through interval notation. Again, if you did Nevada Fit, you've already seen this. So this might be a little bit of review, but it's a pretty short section. So lecture might be pretty short. I'm just going to break it into some shorter segments. So let's go ahead and first just start talking about what interval notation is, why we use it. So most of the time when you're solving equations, you get one solution. So x equals some number. But when you're solving inequalities, you get an entire range of solutions. And so sometimes solutions are an interval of numbers So we use interval notation to express our answers. And so what we want to be able to do is go from interval notation to an inequality and then graphing that. So we're going to have basically three different ways of writing the same thing. So let's go ahead and look at the different cases that we might see with interval notation. And there's quite a few of these. So some of these are really closely related, but I'm going to go ahead and just list out all of them. So that you can see all the different kinds of cases we might see, and then we'll jump into some examples. So first case is if we have the interval. So with intervals, we're going to either have parentheses or brackets around two numbers. And so the interval from A to B, we write as, it looks kind of like an ordered pair. You're going to have parentheses and then your two numbers listed with a comma in between. Actually, let me back up really fast. I'm going to list something else. So I'm going to have the interval on the left here. And then right below that, I'll put our interval from A to B with parentheses. In the middle, I'm going to have the inequality. And then on the right, we'll see what the graph is going to look like. There we go. So again, first one with parentheses from our numbers A to B. So what this is saying is that our solution for X or whatever variable we're working with is somewhere between the numbers A and B. So if these were, for an example, a 1 and a 2, that means that our solution is somewhere between 1 and 2. So it could be 1.5. It could be 1.6, just somewhere in between 1 and 2. And what these parentheses mean is that we can't include those numbers. So our solution will never be exactly 1 or exactly 2, but anywhere in between is perfectly fine. 1.99999 repeating is fine because it's between 1 and 2, but not exactly 2 or 1. And so what the inequality is going to look like is our number X is somewhere between A and B. And since it's not equal to, we're going to use less than signs and then put A and B on the left and on the right. So it means X is bigger than A, but less than B. So the graph is going to be a number line, and we're going to take our 2 points A and B, or our two numbers A and B on the number line. And then the solution is anywhere in between A and B. And since we can't include those, we're going to put parentheses at both of those facing inwards. So your graph should look pretty similar to your interval notation. And so one thing you might have seen in high school was the open and closed circles. Those are the same kind of idea. Open circles are now parentheses, and closed circles are going to be brackets. So we're using parentheses and brackets, not the open and closed circles in this class. So now let's go through and take a look at the other cases. So case number 2, if we have brackets on both of these numbers, so bracket A comma B bracket, this just means that now we can equal these numbers. So our inequality is going to be A less than or equal to X less than or equal to B. And then our graph is almost exactly the same, but now we have brackets on the A and the B, still shading in between. All right, so those are two possible cases we might see. The first one with those parentheses is what we call an open interval. When they're both brackets, we call that a closed interval. And so what we're going to see next is kind of a mix between those two. So it's going to be half open or half closed. Both of those are the exact same thing. So we're going to see the case where we have a parenthesis at A and then a bracket at B, and then the other way around. So a bracket at B, sorry, other way around. Bracket at A and then a parenthesis at B. So these are called either half open or half closed. And again, I can call either of those half open or half closed. I'm not referencing a specific one here as half open or half closed. Those are just two different names for these types of intervals. So the inequalities are, again, pretty similar. Wherever we have a parenthesis, we're going to have a less than. Wherever we have a bracket, we're going to have a less than or equal to. So now we still have our X in the middle. In our first one where we have a parenthesis at A, we're going to have a less than, and then A on the left. And then since B has a bracket, we're going to have less than or equal to B. And then it'll just be switched for the one below because we have a bracket at A. So we're going to have A less than or equal to X, and then less than B because of this parenthesis. So now the graphs of these two, again, pretty similar to what we saw before, except with the exception of the parentheses and brackets. We're still going to have our A and B on both of these number lines. We're still going to shade in between because any of the numbers in between A and B are still a solution. It just depends on whether or not we can include A and B. So on this first one with the parenthesis at A, we're going to bring that over to the graph and put a parenthesis on A. But the B has a bracket, so we're going to put a bracket on B. So that just means that with our interval, any number between A and B is a solution. A is not included, so we can't have that number as part of our solution, but B is included. So whatever the number B is going to be part of our solution. Same kind of thing with this bottom one, except now we're going to have a bracket at A and a parenthesis at B. So these are kind of the main ones where you have a number for both your A and your B. Now we're going to take a look at the case where you have an infinity for one of those. So let me write out our headers here again. So interval, inequality, and graph. Same as before, we're just going to add to the list. So now let's take a look at the case where we have infinities. So let's say we have the interval from a with a parenthesis to infinity with a parenthesis. So infinities are always going to have a parenthesis next to them because we can't actually equal infinity. It's not an actual number. And so what this is saying is that any number from a up to positive infinity is a solution. So that's saying any number bigger than a works. So our inequality is going to be x is greater than a. We're not going to include that infinity because x greater than a is telling us any numbers from a up to infinity is a solution. So we don't need to include that infinity. And then our graph, we're just going to put a in the middle. And x is greater than a, so any number bigger than a with a parenthesis there is a solution. So we're going to shade everything to the right of a. And keep in mind that the right side of the number line is positive infinity. The left side is negative infinity. So everything down into the negatives. So I'm going to go ahead and just list out the rest of these. The big thing is really just being able to go between these in some examples. So I'll list out the rest of these and then we'll jump into those. So our next one, we're going to have a to infinity with a bracket at a. So this is x greater than or equal to a. And our graph is going to look almost exactly the same. The only difference is that we're going to have a bracket at a, shade everything to the right. And then we have the case where we're going from negative infinity to a. So let's go from negative infinity to a with a parenthesis. So this is any number from negative infinity to a, so every number that's less than a. So x is less than a. And then our number line here, still going to have a in the middle, but now we want everything less than a. So we're going to shade to the left, and now our parenthesis is going to face the left-hand side of that graph. Same thing, except now we're going to put a bracket there. So negative infinity to a with a bracket. So this is x is less than or equal to a. And then graph, almost exactly the same, but now we have a bracket at a, shade to the left. So one final one, and this is kind of a special case kind of solution that we're not going to see a whole lot. But if we have the interval from negative infinity to infinity, this is every single number on the number line. So there's no way to actually write this as an inequality. So we're just going to put all real numbers. And then the graph is going to be the entire number line because it's every number from negative infinity, whoops, to positive infinity. So I'm going to make a couple notes and then I'll start a new segment for the examples. So in general, whenever you see a less than or equal to or a greater than or equal to, we're going to use brackets because that means we can equal the number. And then if you see a less than or a greater than, or if you're using positive infinity or negative infinity, you're going to use parentheses. So we'll apply this stuff in the next segment. I'm going to stop there just so these aren't too long, and we'll go through and do some examples.